All right, day 2 of CES 2026 is in the books. And wow, there was one theme that was just everywhere. Artificial intelligence isn't just floating around in the cloud anymore. Nope, it's getting physical, it's getting its hands dirty, and in this explainer, we're going to break down exactly what that looks like.
You know, for years and years, we've talked about AI as this abstract thing, right? This giant brain living in some far-off data center. But the biggest, most mind-blowing reveals this year, they weren't about some smarter algorithm in the cloud. They were about intelligence you could actually see and touch and interact with.
So the real story of CES Day 2 is all about physical AI, and we're going to look at how this is happening in 3 key areas. First, a whole new wave of robotics. Second, the rise of this subtle, ambient AI. And finally, a massive acceleration in the race for self-driving cars. And hey, this isn't just some vague concept. Caterpillar dropped this incredible line to describe its new AI system for their construction gear, a digital nervous system. I mean, that just perfectly captures this whole shift. This isn't AI sending suggestions from some cushy office, it's an intelligent system running right there on the machine, in the mud and the dust.
So, that's the big question, isn't it? How do you go from a really cool marketing slogan to something that's actually real? Well, it all starts with giving that intelligence a body to work with.
So first up, the new wave of robotics. Seriously, the show floor was just packed with them. And not just as cool demos either. We're talking about a maturing industry. You're starting to see these different philosophies emerge for how these robots, humanoids, and other helpers are actually going to tackle physical work in our world. And you can see these distinct strategies taking shape. You've got Neurobotics, and they are all about speed and making their bots agile enough to work in our spaces. Then you have Fourier Intelligence, doing the complete opposite for healthcare, where everything, and I mean everything, is about safety and predictability. And then there's Agibot, and their bet is on building a whole family of specialized bots. It's just so clear that this is not a one-size-fits-all race anymore.
But what's really interesting is that across all these different companies, you can see the whole industry is growing up. We're seeing shared intelligence stacks, which means a skill learned on one robot can be transferred to a totally different one. They're all using force sensing so they can work safely around us humans. And they're embracing different shapes and sizes, like 4-legged bots for rough terrain. Oh, and a special shout out to Agibot's Omni Hand. What a huge leap forward in dexterity for those delicate, fine motor tasks.
So how in the world does a Caterpillar excavator use AI on a job site with terrible or maybe even zero internet? The answer is something called edge computing. Instead of sending data all the way to the cloud and back, all the processing, all the thinking happens right there on the machine. This is absolutely critical for real-world industrial systems where you need split-second decisions and you just can't risk a lost connection.
And this right here, this is a brilliant illustration of 2 totally different ways of thinking about physical problems. On one side, you have Synogen's Rover X3. It's this tough little bot that uses super sophisticated software to figure out how to climb stairs all by itself. But then, on the other side, you have Dream's CyberX, which basically said, you know what? Why make the robot smart enough to climb stairs when we can just build a little elevator for it? It's a pure hardware solution to a physical problem, and it's just a fantastic reminder that clever engineering comes in all sorts of different forms.
But okay, putting AI into these big, obvious robot bodies is only half the story. The other trend, and this is just as important, is seeing AI get so small and so integrated into things that it basically becomes invisible.
And that brings us to our second big theme, ambient AI. This is all about intelligence that's designed to help you and then just disappear. It's tech that wants to reduce our screen time, not add to it.
This less is more idea was everywhere you looked. Take the Reno X3 Pro smart glasses. They aren't trying to create some immersive augmented reality world, they're just a super lightweight AI terminal for quick info. Or the LunaBand health tracker. It has no screen at all. It gives you coaching through voice and an app without constantly distracting you. Even the Clicks communicator, bringing back a physical keyboard for people who miss that tactile feeling. The common thread here is technology that serves you, without demanding all of your attention. Now, all of this physical intelligence needs physical power. And just look at the jump here. A standard car outlet gives you about 100 watts. The new Bluetti Charger 2, it delivers up to 1200. That's a total game changer. It means you can power a mobile workstation or recharge these big systems on the go. This is the kind of foundational physical tech that makes all these other AI applications actually possible out in the real world. And that brings us perfectly to our third and final area where physical AI is making these huge strides, the vehicles we travel in. The race to full autonomy is really heating up.
And we're seeing two very different strategies start to emerge.
Yeah, the approaches really could not be more different. On one side, you've got Ford, the established giant. They're integrating AI into their existing ecosystem, and they're building a universal platform to scale up production. And on the other side, you've got a company like Tensor, who is building a vehicle from the ground up around a massive AI supercomputer. Ford's plan is super methodical. It's all built on scale. So in 2027, they're going to launch their universal platform to slash costs. And that becomes the foundation for their next big leap in 2028. They're targeting eyes-off, point-to-point driving. It's a very structured, step-by-step rollout.
And then there's Tensor. Just look at that number. 8,000 trillion operations per second. That is the kind of processing power we're talking about inside their robocar. This is so much more than just an upgrade. It's a massive statement. They believe that to truly solve autonomous driving in our complex, messy cities, you need an absolutely unprecedented amount of computing power right there on board.
And look, this isn't just some tech demo. Tensor has a very clear path to market. They've built a true Level 4 system, and that means the car can handle everything in certain areas with no human intervention at all. They've already got the permits for driverless testing in California, and this is the crucial part. They're integrating directly with Lyft. So their cars are being designed from day one to work in a real-world ride-hailing network, with the first markets planned for 2027.
So, after seeing all of this, what's the big picture here? We've seen robots on the factory floor, we've seen invisible AI in our glasses, and we've seen supercomputers on wheels. It all points to one thing: the era of embodied AI has begun.
You know, if there's one single thing to take away from CES Day 2, it's that the entire conversation has changed. AI is breaking out of the data center. It's becoming a physical, active participant in our world, stacking boxes, monitoring our health, and driving our cars. The intelligence is finally getting a body. And that leaves us with a final, massive question to chew on. For so long, we've had to adapt our physical world to fit our digital tools. But as our technology becomes more and more physically capable, how is our world, our jobs, our cities, our lives, going to change to adapt to it?